How does a loose nut rotate against gravity and come off a bolt? Under appropriate vibration conditions, a loose nut can rotate on the bolt thread against gravity and then fall off the end of the thread. When this occurs on a product, the part that the bolt holds together can become detached with sometimes serious consequences. The bolt shown here is experiencing vibration from a battery-powered motor contained in the bolt shank. The direction of rotation of the nut can be reversed by reducing the vibration amplitude. In this case, this is achieved by touching the end of the thread. Research on more sophisticated test arrangements confirms the propensity of a fastener to rotate against gravity at high vibration amplitudes and rotate in the direction of gravity at low vibration amplitudes. The cause of the nut rotation under vibration is thread clearance, allowing the nut to move laterally relative to the bolt thread. Such movement can be seen in the slow motion video. One way to prevent such nut rotation is to eliminate the thread clearance. A common way this is done is by using fasteners having a prevailing torque. The prevailing torque is the torque needed to run the nut down the thread before clamping of the joint occurs. There are two main types of prevailing torque nuts: nylon insert and all metal. The nylon insert, often referred to as a nylock nut, is defined in ISO 7040. The second variety is the all metal nut that generates the prevailing torque, usually by distorting the threads at the top of the nut. This type of nut is defined in ISO 7042. A bent beam type of nut is a popular variety of such a nut. A prevailing torque nut, even when loose, prevents lateral movement of the nut relative to the bolt thread and so resists rotation. Such nuts are often specified to assist in preventing detachment of the nut from the bolt if the fastener is inadequately tightened or the joint sustains an overload condition. A word of warning: this type of nut is sometimes called a self-locking nut. The name is a misnomer since such nuts do not lock the nut to the bolt and so do not necessarily prevent self-loosening. Under a Juncker transverse vibration test, a fastener having a prevailing torque tends to self-loosen, rotate, and then stop, retaining a small level of preload. A word of warning: if the joint is subjected to axial as well as transverse loading, and if the joint is not adequately preloaded, the joint plates can be pulled apart, forcing a prevailing torque nut off the bolt thread. This is discussed in an article on the Bolt Science website.